This is Algebra 1, Lesson 28b, Functional Notation. We're going to start with this equation, y equals x plus 2. I want us to find the value of the variable y if x is equal to 5, if x is equal to 0, and if x is equal to negative 75. So you've kind of been doing this. You've been given not an equation, but you've been given an expression, and you have to substitute this value in for the x, right? And you'll get an answer, or this value, or this value, okay? I'm going to do that. I'm going to kind of organize it as a chart. If the x value is this, then my y value is this. That's how I'm going to organize it. So they told me to try 5 first. So I'm going to put a 5 in here. If I do that, then what I'm really saying is y is equal to 5 plus 2, because I just substituted the 5 in for the x, and then I work it out, and I find out that that is 7. 5 plus 2 is 7. Let's try the second one. What if x is 0? Well, now I'm substituting in, instead of this x, I'm substituting in a 0. 0 plus 2 is 2. That would mean if x is 0, y is 2. All right, let's try the third one, negative 75. That would mean y is equal to negative 75 plus 2, which would be negative 73. Now notice, every value that I tried for the variable x gave me one value of y that goes with that value. Meaning, again, here, if x is 5, y has to be 7. If x is 0, y has to be 2. If x is negative 75, y has to be negative 73. That is the definition of a function. If there is exactly one value of the variable for each replacement value of the variable x, okay? Exactly one is the key here. Exactly one value. So I try an x value and I get exactly one y value. I didn't put in a 5 for x and find out that there could possibly be 2 answers. And later you'll get to some equations where there could possibly be 2 answers, and that would not be the term we're about to learn here. Let's fill in the next blank. That means that y is a function of x. And we're going to look at some real life examples of functions in just a second, okay? So hold on for that. It'll help it make more sense as to what this is. But first, a little bit of the algebra. Since y equals x plus 2 is a function, and we see that, you put in one value for x, you're going to get one value for y, we can write it in function notation. Now, I want you to look at this. This is kind of weird looking, okay? Notice how that looks different from the way I wrote it up here. I'm going to erase my highlighting, and we're going to highlight it in a different color here. I want you to look at that equation and that equation, okay? They look the same on the right side of the equals, and if you notice on the left side of the equals, here we had a y, but here we have this f and x in parentheses. Okay, so let's talk about how you read that and why in the world they're going to write it differently. Why would they want to write it that way? Well, first, you read this f of x. F of x is equal to x plus 2. That's how you would read this. F of x is equal to x plus 2. So when you see this, you say f of x. Now, important note, f of x does not mean f times x. That does not mean that. That is not at all, okay? That's not what it means. It's not an operation. It's just a name for the function. Let me show you what I mean, okay? It's just a way to name the function. So let's say you have a couple different functions, okay? We have 3 functions here. And what if I tell you that I want you to evaluate one of those functions, and I want you to evaluate them for a certain value, and you're like, well, which one? Which one do you want me to evaluate, right? How would you know which function I wanted you to use? If I said, I want you to find y if x is equal to -3. Well, how do you know which function to use? But what if I renamed these functions and I called this one f of x equals x plus 7? And what if I called this one g of x equals x squared minus 2? And what if I called this one h of x is equal to 2x cubed minus 3? Then instead of giving you this vague instruction, I could say find, let's see, which one are we going to use? Find h of -3. So what would that mean? Well, that would mean I know I'm not using this function and I'm not using this function. I found here that I'm going to be using h of x. And this would mean that instead of the x, I'm going to put in a -3. So I would write it like this. H of -3 is equal to, and then every time I see an x in this right-hand side of the equation, I'm going to replace it with a -3. Copy everything else exactly the same except for that x. And again, remember, we're going to put it in parentheses. So then I could use my order of operations to work this out. I'm going to scoot this over. I could use order of operations to work this out. The left side is just h of -3. The right side, I would do this exponent first. -3 times -3 times -3. Well, 3 times 3 is 9 times 3 is 27. So -3 times -3 times -3 is -27. Copy down the 2 times it and the -3. We can double it here. Next, we would multiply -54 minus 3. And then subtraction is the same as adding the opposite. So -57. So that means h of -3 is equal to -57. So essentially, it's the same thing you've been doing when you evaluate an expression, but it's a different notation. So I want you to think of it this way. This is just a name, like you have a name. This function, we'll call him Frank, and maybe this is George, and this is Henry. Okay? It's just a name to keep it from getting confusing about which function that they are referring to. But remember, it's not an operation. All right, now let's backtrack a little about functions. Here's a real life example that's sort of a function. This is a vending machine. You go in, you pay, and you press the button for the snack that you want, okay? When you press the button, you should get the snack that you want if everything works correctly, right? We all know sometimes they don't work correctly. But you press the button, you get the snack you want. You don't press the button and get 2 snacks or 3 snacks or a snack you didn't want, okay? So that would be an example of a function. Here's another example. You go to the post office and you take a package you're going to mail, and you give it to them so that they can weigh it and determine how much postage you have to pay. So the amount that you pay is a function of the weight of your package. You see? All right, here, what about temperature? Each time has its own distinct temperature. It's not going to be 3 o'clock and be 50 degrees and at the same time be 91 degrees, right? So the temperature is a function of the time of day. And then here I found this little interesting tidbit. Here you've probably seen this before. This is an example of a function. You may not have seen it written that way, but this just means that your Fahrenheit temperature is a function of your Celsius temperature, which means if you know your Celsius temperature, you can put it into this expression on the right, 9/5 times the Celsius temperature, and then add 32, and that'll give you the Fahrenheit temperature. That's just the conversion, and this is a function. All right, one more. We've got paychecks. okay? Or direct deposits, I guess. So when you get paid, if you have a job, you work a certain number of hours, and that earns you a paycheck. So your paycheck is a function of the number of hours that you work. So if you work, and let's say you make $15 an hour, then that's going to be $15 times the number of hours that you work. That's a function. You're not going to work 1 hour and maybe one time you work 1 hour, you get 15, but another time you work the 1 hour and you get some other amount, right? 1 hour is always 15 before deductions, that is. These are all examples of functions.